Dear students, now we will discuss about rectifier, which is an important topic in our semiconductor, and then we will discuss how PN junction diode will act as a half wave rectifier. So first of all, what is rectifier? Rectifier is an instrument which converts alternating current to direct current. AC to DC. AC means whose magnitude and directions both will change continuously. This is positive direction and this will be negative direction, and it converts AC to DC. DC means only unidirectional, or the current which is only one direction. So how the rectifier will work? Or diode means PN junction diode is a half wave rectifier. First we will draw the diagrams. Here we will consider a transformer. Transformer means primary coil and secondary coil. And the primary coil is connected to an AC input source here we will connect diode. This is your P and this is your N. So this is your PN junction diode, which is connected with the load resistance. Load resistance means through which output will be obtained. Now, when the AC input source is supplied through the primary coil, then an induced EMF will be set up through the secondary coil. Why? Because of your mutual induction. Because there are two coils which are coupled with each other. So, when the induced EMF will be set up, then its direction will be like this. A will be at positive and B will be at negative. Or we can say P is connected to positive and N is connected to negative. That means during this time the PN junction diode will act as your, or it will work in forward biasing. Forward biasing means it will offer your low resistance means during this time current will flow. Current will flow means output will be obtained. Where output will be obtained? Through the load resistance, means RL. And what is the direction of the current? This is a positive terminal. So obviously the direction of current will be like this. This is most important thing. You have to mark the direction of current here. Now during next half cycle the process is same. That means when we apply the input, then the output or the EMF, induced EMF will set up through the secondary coil due to a mutual induction. But the direction will be opposite. Means at that time A will be negative and B will be positive. That means P terminal is connected to negative and N is connected to positive. Or you can say during this time the PN junction diode will act or it will work in reverse biasing. Reverse biasing means it will offer high resistance. High resistance means no current will be flow, or you can say I is equal to 0. I is equal to 0 means no output will be obtained through the load resistance. So from the above discussion, with the help of this diagram, our conclusion is when the PN junction diode is in forward biasing, at that time output will be obtained, and during your forward biasing the potential barrier will be reduced and the depletion layer will also reduced, so that the output will be obtained. Hence, if we want to study the output and the input characteristics of half wave rectifier, then suppose this is for input and this is for output. Input, we are supplying input every time, so the input graph will be continuous. But for your output, only in forward biasing the output will be obtained, and during reverse biasing the output will be 0. Again same process will repeat. Next, in forward biasing output will be obtained, and reverse, during reverse the output will be 0. So mark these two characteristics. Input characteristics will be continuous, but the output characteristics will be only for your forward bias. So this is all about your half wave rectifier.